let's start work for the day. Thankfully the last video got uploaded pretty smoothly. I didn't have to do it twice. And the rendering and the the audio processing also went by without issue. So let's do a little recap. Yesterday we roughly ended the video here, and the only changes that I made since the video ended is that I realized that this tensor update didn't have the correct type. So I was missing the conversion functions here, so I put them in. Also, I did a little change. Last time I said that we should first do the log and then the conversion, but I cannot change my mind. Even though it's going to be slower to do the log in float 64-bit format, I want to go for numerical accuracy instead of performance here. So that's the only thing that I really wanted. I also swapped the exponent and the convert here for the sake of numerical accuracy. First we take the exponent and then we do the conversion, whereas previously we had that be done in the opposite order. I do want to go for numerical accuracy instead of performance. I mean, there's so much stuff going on here. It's not like doing the exponent in float 64 is going to kill performance. Okay, so fixing the type error here, because when the conversion wasn't happening, that was the only thing that I really changed. That was a significant change. I created this add function so I could give it a type annotation, and now this is being done like so. The only thing we're going to do, the first thing that we're going to do today, I realized that we're actually loading we actually made the tensor dimensions in the wrong order. We want the innermost dimension to be the one that the threads load first. So, for example, here we have the thread ID and the sequence ID. And when the threads load from the actions tensor, it's going to be non-contiguous. And if we swap the sequence ID and the thread ID, the loading would be done in contiguous order. So we should be doing that everywhere. I simply missed this the first time around, and we should fix this. It's merely a performance optimization, not a correctness optimization, but it's worth doing, because when doing GPU programming and CPU programming as well, it pays to put the data in contiguous order. Now let me just set up the keyboard, raise the table, and we're going to then change this. And after we have finished making this change, we're going to move on to testing. And we're going to actually test this by simply putting a bunch of print statements and looking at the outputs. We cannot do much more for the time being. We're just going to take a look at the outputs and see whether everything is sane. Oh yeah. Also, when it comes to the value updates, I don't think we need the count, since the count will always be 1. Let's also change that as well. And okay, let me try it like this. Okay, now But if we try the swapping the dimensions, like this third ID with sequence ID, we get no type errors because they're both integers. So what we want to do is, when we change the type, we want to have a bunch of type errors everywhere in the code base, so we can see where we need to make the changes. So we're going to go into the thread ID. God damn it, what's going on? We're going to go into the thread ID, and then we're going to make this a record thread ID. And now you should be able to understand what I'm doing. Okay, let's do Control D. We're going to cut this. And we're going to move it to the right. And now, if you look in the code base, you can see it on the sidebar. There are a bunch of type errors. Oh yeah. I guess this, I didn't think about this, but this should also be thread ID equals threads per block. And now we have to pretty much, yeah, change everything here. D. Oh, this fucking feature is amazing. Yeah, you do learn new things every once in a while, it seems. And we're applying the thread index in a bunch of places. Okay, how are we going to do that? Do we want to maybe factor out? Yeah, it's pretty much thread index fucking everywhere. Okay, okay, how about this? Let's do thread ID equals thread ID equals thread index. And you can guess what we're going to do with this. Let's do Control F, thread ID, thread ID. Yes, I think this is also thread ID. Okay, this is on thread ID. And now what I have to do is simply swap the positions, like we also got to remove the count here. Oh wait, we actually still have an we have an error here, yeah. An error didn't see it. Oh yeah, this should be thread ID. Thread ID. Oh yes, okay. Tensor atomic add. Oh yeah. Okay, I get why this is like this. Okay, so we're going to just put 1 as the count. over here. I mean, there's no need to actually put that in. Wait, yeah, it needs to be over here. There's no need to put that in a global array. We're just wasting memory and computation. Not bad. Tensor set, trace actions. Yeah, this needs to be the thread ID. Okay. Yeah, okay, that takes care of that performance optimization. Need some performance optimizing. Let's sketch. So what do we have left? I mean, one thing we still need to do is make the row map a grid-wide operation. We need to make use of the entire GPU to do this row map instead of just a block. But I've been thinking about whether I want to do this right now, and I really don't. It's pretty much a secondary thing, and we don't need to test it at the moment. Instead, what I want to do is simply go through this entire thing once and print out what's going on inside it. I kind of want to make sure that everything is, at the very least, that everything is going the way I envisioned inside it. I mean, there's certainly, this is a lot of code and there is a lot of room for error. I definitely, yeah, I've been thinking that I really do admire this counterfactual regret algorithm. It feels like it has a lot of wisdom in it. But deep learning, on the other hand, doesn't really inspire the same kind of feeling from me. Deep learning is the simplest thing possible, and the simplest thing possible isn't necessarily what we need to get to the root of intelligence. This algorithm actually does capture a lot of what's going on in reasoning. Maybe it's worth trusting it a little. Yeah, I should have started with Tabular CFR and then moved on to everything else instead of getting railroaded into what's popular in RL. What's popular in RL, I mean, for the past 10 years has been pretty much policy gradients and those kinds of deep learning based methods. Well, let's begin the testing. Okay, first of all, one thing we have to do is yeah, I think we need to put some barriers between these steps. Tensor set. Wait, policy and current. Okay, I'm kind of confused whether. I mean, yeah, we don't need a barrier right here. This is the only thing. We probably do need a barrier. What did I do? Barrier CTI sync 0. Okay, I'm not exactly sure about the barrier here, but we definitely need one after the atomics. We need a barrier here so all the threads can see the results of the atomics. Okay, this one I'm certain. This one I'm not. Okay, as the first thing, what we want to do is print out this reward here. We're passing in minus 13 at the top, and I want to see whether that minus 13 ends up coming out. That's the very first thing that we need to do. So console. Of course, the very actual first thing is we need to make sure this even compiles. I accidentally ran the PowerShell. Fuck's sake. Spiral build file. Oh, right. What's this function even called? Oh, test. Okay. Main. Spiral build file. Okay. We're building this file. Now let's see. It actually did build. How much? 6,000 lines of code. Oh, there are a bunch of arrays here. Okay, there may be these arrays are a bit maybe too large for the sake of testing, so we're probably going to reduce the sizes later. But now let's just print this out. We should be getting minus. This keeps warning me about division by 0. Okay, first of all, let's just add this warning. Let's go into Corcula base, and we're going to suppress that warning because this -1. I mean, this -1 divided by 0. That's just a way for us to get negative infinity, I think, because we don't have the inbuilt constants. I mean, we didn't have them in NVRTC. Now we're using NVCC. We need to import some kind of library for it. Who cares? Okay, now let's try build this. Oops, not this, but okay, we don't need the test main, we don't need the loop. Okay, let's build. Okay, now we don't, it's not bothering us about those divisions by 0. Error, calling a host function closure, Okay, so closure 6, that's probably one of the reduction functions. Let's take a look. Closure 6. I mean, it is a device function. So this is the constructor, and the constructor is not a device function. Okay, I guess we're going to have to change that. Okay, let's close this here. We're going to open the IDE, and then we're going to check out where the closures are being code generated on the CUDA side. Okay, this is 10, 19. The closures. The closure constructors now have a device annotation. I mean, yeah, we probably tested this with NVRTC before, and there it worked, but over here it doesn't, so we need to change it. Device union operator. Okay, so the structure does have this device, and we're only missing the wait, this is the union, not the closure. Here's the closure. Print body, whatever. Closure arguments. The pointer has this device annotation, vanilla or closure. Okay, so this is the constructor, this is the destructor. Yeah, it's going to need, both of them are going to need annotations. Device. Okay, I think this is how it should be done. Let's give it a try. Like, I'm not sure whether the default destructor really needs annotation, but we'll see. Yes, go plugin. Okay, did this. I still didn't publish. Right now I kind of trying to use the keyboard differently. I have it more spread out and then put the touchpad in the middle. It's actually very difficult to use the mouse like that. I think I've been overusing the mouse. I don't know what it is about the mouse that makes my hand hurt, or hell, even the arm, but there must be something about it. I simply have no idea. Okay, so yeah, and now we can finally run the new version of the language. It's running it. Let's dispose of this terminal. Let's build the file. Yeah, okay, here is it. Now we can try running this. Nan. Okay, so we do have some debugging to do. Yeah, it's a good thing to do the sanity checking. Okay, so this is where it was. Wait, I'm a bit confused. So here we are setting the reward, but it's yeah, we're doing a MapReduce. So this thing goes into the output, and this gets returned. Okay, so final reward. And we're also going to put a print statement here, like console write ln reward. Let's see what happens. Final reward is a nan. Reward nan. So okay, at the start it's minus 13. Then at the end of the first loop it becomes nan. Okay, so I mean a lot of these arrays aren't even initialized to 0. That could be what's causing the trouble. Like we're doing tensor creation. Reward and count. Okay, let's print out these two. I want to see what comes out. Policy current console write ln. Oh yeah. I mean, okay, these are being initialized all to 0. I think, yeah, I think TensorCreate is in fact initializing them to 0, even though it's supposed to be undefined. But I have yet to actually see the TensorCreate output array that's anything other than filled with zeros. Okay, so it's like this. Reward and count. Okay, so we only have the 4 actions. Yeah, that makes things easier. Is this thing here? I forgot to test whether it's like 0. And this ends up being none. Okay, if count. Else we just make it 0. What a stupid error. Okay, did we maybe forget this in some other place? I mean, we shouldn't. Yeah, you have to be really careful with the division. Okay, never mind. Let's... Oh, maybe this thing here. Like... if value threshold greater than... If be greater than value threshold... I mean, the value threshold is like 100, so it won't be... So there's no chance it will be dividing by 0 here. Okay, let's try this again. Oh great, now it's propagating the rewards properly. It gets minus 30 in, and at the end of the loop it still gets minus 13 out. Perfect. Damn. Okay, let's see. So fixed the invalid division by 0. Oh, nice. Now, it's not a given that everything here is right, but yeah, we're going to have to print out the policy updates, but it's much more likely that... okay, let me just put this video on the timeline, and then we're going to continue. Well, let's begin the testing. Okay, first of all, one thing we have to do is yeah, I think we need to put some barriers between these steps. Tensor set. Wait, policy and current. Okay, I'm kind of confused whether... I mean, yeah, we don't need a barrier right here. This is the only thing. We probably do need a barrier. What did I do? barrier CTI sync 0. Okay, I'm not exactly sure about the barrier here, but we definitely need one after the atomics. We need a barrier here so all the threads can see see the results of the atomics. Okay, this one I'm certain. This one I'm not. Okay, as the first thing, what we want to do is print out this reward here. We're passing in minus 13 at the top, and I want to see whether that minus 13 ends up coming out. That's the very first thing that we need to do. So console. Of course, the very actual first thing is we need to make sure this even compiles. I accidentally ran the PowerShell. Fuck's sake. Spiral build file. Oh, right. What's this function even called? Oh, test. Okay. Main spiral build file. Okay. We're building this file. Now let's see. It actually did build. How much? 6,000 lines of code. Oh, there are a bunch of arrays here. Okay, there may be these arrays are a bit maybe too large for the sake of testing, so we're probably going to reduce the sizes later. But now let's just print this out. We should be getting minus this keeps warning me about division by 0. Okay, first of all, let's just add this warning. Let's go into Corcula base and we're going to suppress that warning. Because this -1, I mean, this -1 divided by 0, that's just a way for us to get negative infinity, I think. Because we don't have the inbuilt constants. I mean, we didn't have them in NVRTC. Now we're using NVCC. We need to import some kind of library for it. Who cares? Okay, now let's try build this. Oops, not this, but okay, we don't need the test array, we don't need the loop. Okay, let's build. Okay, now we don't, it's not bothering us about those divisions by 0. Error, calling a host function closure, Okay, so closure 6, that's probably one of the reduction functions. Let's take a look. Closure 6. I mean, it is a device function. So this is the constructor, and the constructor is not a device function. Okay, I guess we're going to have to change that. Okay, let's close this here. We're going to open the IDE, and then we're going to check out where the closures are being code generated on the CUDA side. Okay, this is 10, 19. The closures. The closure constructors now have a device annotation. I mean, yeah, we probably tested this with NVRTC before, and there it worked, but over here it doesn't, so we need to change it. Device union operator. Okay, so the structure does have this device, and we're only missing the wait, this is the union, not the closure. Here's the closure. Print body, whatever. Closure arguments. The pointer has this device annotation, vanilla or closure. Okay, so this is the constructor, this is the destructor. Yeah, it's going to need both of them are going to need the annotations. Device. Okay, I think this is how it should be done. Let's give it a try. Like, I'm not too sure whether the default destructor really needs annotation, but we'll see. Yes, go plugin. Okay, did this? It still didn't publish. Right now I kind of trying to use the keyboard differently. I have it more spread out, and they put the touchpad in the middle. It's actually very difficult to use the mouse like that. I think I've been overusing the mouse. I don't know what it is about the mouse that makes my hand hurt, or hell, even the arm, but there must be something about it. I simply have no idea. Okay, so yeah, and now we can finally run the new version of the language. It's running it. Let's dispose of this terminal. Let's build the file. Yeah, okay, here is it. Now we can try running this. Nan. Okay, so we do have some debugging to do. Yeah, it's a good thing to do the sanity checking. Okay, so this is where it was. Wait, I'm a bit confused. So here we are setting the reward, but it's yeah, we're doing a MapReduce. So this thing goes into the output, and this gets returned. Okay, so final reward. And we're also going to put a print statement here, like console write ln reward. Let's see what happens. Final reward is a nan. Reward nan. So okay, at the start it's minus 13. Then at the end of the first loop it becomes nan. Okay, so I mean, how do these arrays aren't even initialized to 0? That could be what's causing the trouble. Like we're doing tensor creation. Reward and count. Okay, let's print out these two. I want to see what comes out. Policy current console write ln. Oh yeah. I mean, okay, these are being initialized all to 0. I think, yeah, I think tensor create is in fact initializing them to 0, even though it's supposed to be undefined. But I've yet to actually see the tensor create output array that's anything other than filled with zeros. Okay, so it's like this. Reward and count. Okay, so we only have the 4 actions. Yeah, that makes things easier. Is this thing here? I forgot to test whether it's like 0. And this ends up being none. Okay, if count. Else we just make it 0. What a stupid error. Okay, did we maybe forget this in some other place? I mean, we shouldn't. Yeah, you have to be really careful with the division. Okay, never mind. Let's... Oh, maybe this thing here. Like... if value threshold greater than... If be greater than value threshold... I mean, the value threshold is like 100, so it won't be... So there is no chance it will be divided by 0 here. Okay, let's try this again. Oh great, now it's propagating the rewards properly. It gets minus 30 in, and at the end of the loop it still gets minus 13 out. Perfect. Damn. Okay, let's see. So fixed the invalid division by 0. Oh, nice. Now, it's not a given that everything here is right, but yeah, we're going to have to print out the policy updates, but it's much more likely that okay, let me just put this video on the timeline and then we're going to continue. I've taken that a short break, and while I was in the bathroom I realized what the problem was. So we don't need to debug it. I'm just going to tell you, or rather show you. Now where is it? Yeah, here we have this sampling, action sampling probability. And now if you look at what we're doing here, we are indexing into the policy current, but this policy current isn't a probability, but some unbounded value that happens to be positive. And that's the first problem. And the reason why the updates are all 0 is because, of course, at the very start, this array is 0. So yeah, we have a problem. Okay, so we cannot get the probability of the action like this. Instead, we might actually need to modify the get action so it returns the action probability. Yeah, I made a mistake. Pure and simple here. Okay, get action. Resampling from the average probability. We might also need to just pass in the policy current. policy average, policy current. Okay, so how about we name this like sampling policy. Oh yeah, okay, this is fine. No, this should be no, not like that. Now this should be yeah, policy and sampling. Now I guess we have to, I mean, yeah, we have to basically reshape it. Okay, let's extract these. I kind of feel stupid for doing it like this. Okay, let's. We're just going to have the one on the left be sampling, on the one on the right be policy. Sampling policy and unzip X. Sampling probability, sampling the sampling policy and the actual policy. And I think they call the sampling distribution the representative distribution in various machine learning papers. Maybe I should be calling it like that, but okay, let's make this sampling and actual. Now we also need the actual probability. This one isn't going to have the action ID, so we are going to be doing discrete sampling. I don't think we need to pass. Yeah, we don't need to pass in the RNG. Let's just make sure that this is a float tensor and it isn't. Maybe IJ tensor. Is it like this then? Ooh, okay. Sampling probability. Now let's just name this policy. Policy. Okay, now yeah, we have to reduce both of these to their individual probabilities. And for that we have to do a local reduce. Okay, in all get the probability probs. We must not passing the wrong thing by accident. Okay, so good. Now Okay, let's do this. Action ID and sampling equals get prob sampling probs. Policy equals get prob policy probs. Okay, let me just have a log probability. Let's make this action probability. Right, why is this happening? Okay, now action probability. We have the sampling probability and actual probability. Not bad. Now action probability. Action prob equals action probability sampling. Okay, action probability sampling. Sampling. And this will be action probability policy. Policy. Yeah, makes sense. I simply didn't count on needing the proper probability just to calculate the path probability. How complicated. I mean, in primitives, we should have, yeah, regret, local regret matching, local masked regret matching. And of course, we are making sure that the sum is not 0. And if it's not masked, then it's 0. Pum, 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 pum. Okay. Yeah, I think this should be fine. Maybe we should be... Oh, it seems good thing I have an UPS because the power just went out for like a second. And that would have caused a reset of my computer usually. Okay, I mean, I'm not going to try to abstract this because maybe I could, at least the log. No. We aren't going to do that. It's fine to do it like this. The power really is unstable. I mean, I haven't gotten much use from this UPS. It's kind of acting like a heater most of the time, but now it's really convenient. Okay, so okay, so what we're doing? Yeah, we have this. Now we can run the thing again, and yeah, this beeping sound is just the UPS going off. I guess the power grid is unstable right now. So okay, we have the final reward. That is what is getting printed. We are going to be printing out the update policy. And the reason why we only had an update in the final step is because in the final step the probabilities start out at 100%. Okay, now let's build this, then we'll run it. Okay, what's going on here? Oh, I see. Yeah, as it goes, the reason why the policy updates are bigger here is because yeah, you have to think about the counterfactual regret update. Over here it's like 39, but as we sample the probabilities and then set the actual policy to 0, because of that offset, it ends up making the update bigger. Like we're just dividing the path probability. Sure, this is something to think about. Should even the sampling probability be greater, or should the sampling probability also be set to 0? I mean, set to 1. I mean, the opponent probability just gets offset. Yeah, it's a good thing to actually. It would be a good thing for me to pause and actually think whether this makes sense. I'm not really sure. Like. Why am I in the primitives? Yeah, here we are setting. Here we have this, and would it be better to have it like this or to have it like this? Do we want also to set the sampling probability to 100%? And that's what I'm wondering about here. Let's pause a bit and I'll get back to you. I mean, I cannot thought that how we have now should be correct, but these sampling probabilities will just kind of keep offsetting and keep growing the update. I'm not sure whether that's a good thing. Let me pause. I had time to think about it, and in fact, leaving out the sampling probability is in fact correct. I mean the way that we had it is in fact correct. That's what I want to say. And let me explain why that is. Like, let's go into Excalidraw. Now, let me pause. I'm kind of going at this with the intention of, actually would prefer if we could leave out, if we could just set the sampling probability for the player ID to 0, like we do for the policy. But that would lead us to incorrect results. We have to think about how going through the game node, through the game tree would behave, for example, with this particular update and the one that I previously suggested. So over here, imagine that this has a high sampling probability, like going from here to here, and this thing has a low sampling probability. So if we had like if we treated all of this as, for example, as having if we ignore the effect of the sampling probability, imagine we had particular sampling probability for this. For example, this one has a high sampling and this has a low sampling. And if we treated this as having equal sampling probability, then this node and this node would in effect be visited the same amount of times. And this red node is the reward going into that node. So it in essence will get the same number. These two blue nodes are the same node, just alias to different world states. And this one would get, for example, imagine what would happen if this node at this node it get -1 with 50% probability and +13 with 50% probability. That would in essence be the expected value of what, +6, yeah, +6 exactly. And that might end up skewing the updates significantly. If instead we took account in the actual sampling probability, we'd correct for that. For example, if this guy had a very high sampling probability and this had a very low, then it would get a lot more negative rewards than positive ones. And in that case, the update would be correct. So that's why we need to account for the sampling probabilities. And the only thing that's really making this confusing is, you know, if you had two more players and they have their own sampling probabilities, which might be different from the policy probabilities, and for the purpose of this thought experiment, we can just ignore that the game 3 even has another opponent. Imagine we could imagine this as having this game as having only a single player. In that case, the path probability probability would always be 100% here, and we only need to consider the sampling probabilities. And in that case, my explanation would make sense. So, in the one-player case, in the case that the game has only a single player, yeah, this would, I think, yeah, it would make sense. It's kind of interesting now that I'm saying it like this, but if you think about the policy gradient algorithms and the actor critic algorithms, they never really correct for their own sampling probabilities. And it's not really a problem in those algorithms. It's kind of interesting, even though this way of thinking is like definitely correct. Maybe this is one of the causes of bias in TD learning. Well, I mean, in TD learning, we don't even have a policy. The policy is just the max over all the values. But if you have something like an actor critic algorithm, yeah, maybe it is a problem there that they're not dividing by the sampling probability. Yeah, I guess you can learn a lot by simply thinking about counterfactual regret. I never really thought about this aspect of importance sampling. Like, okay, in TD learning in particular, because we are kind of taking the max over all the values, the sampling probability would be 100%, so it actually doesn't matter there what the policy is. But in actor critic, when we are kind of using the current policy to sample from, I guess this could be a cause of bias. Sorry, I forgot exactly what I was talking about 2 hours ago, which is like a few moments for you. So we're going to have to go from I don't know, from some point in the past. I've been thinking about the correctness of this, and I don't think it's correct. But having this kind of equation made me realize that, in fact, enumerative CFR is incorrect. I mean, like the whole algorithm, because it's only actually correct if all the states, if there isn't any aliasing between the states. Or rather, I'm not sure. This isn't exactly how I describe it. Rather, I mean, it could have hidden information, but it cannot. There cannot be any aliasing in public information. Otherwise, the lack of this sampling probability could be incorrect. And in fact, I've just realized that I've been thinking of enumerative CFR as having the probability of having the sampling probability of 1, but it would actually be more correct to assume that it has a probability corresponding to a uniform random distribution. This is something I've realized just now. It's kind of difficult to explain or to prove, The problem is that with these kinds of complex algorithms, you can only kind of imagine example cases and try to draw inferences based on that. So I'm kind of trying to narrow down what is right and what isn't. I came up with some like examples to explain to me what would be correct in terms of these updates. But I don't feel like drawing them out. And anyway, this is the sampling version of the update, and it's indeed correct. One thing I realized though, that I made a serious mistake. And that serious mistake is the way I'm calculating, or rather, the way I'm updating the values. I should be updating the values with these. I should be multiplying both the numerator and the denominator with this path probability. And instead I'm just using the count of 1. So that means that the value update will be biased based on the how do I put that, sampling probabilities. I mean on the implicit sampling probabilities of going through the program. You know. Wait, I wanted to add Rob. So, okay, here we have the value. And oh my god, why the hell are we calculating these things inside the local map, inside this loop? Just what was I thinking? Okay, so that's one thing. But I'm also wondering whether the update okay, here we have the log path probabilities. Yeah, we have the row gather map. We have the thread ID. We have the update policy. Wait, I mean, when we go into row gather map, I think this update policy won't have the correct thread ID anymore. That's what I'm wondering about. If we are accessing it in row gather map reduce. So what the hell is going on here? I mean, are we indexing into this anywhere? Oh, this is the output. Oh, I see. Oh, right. Okay, this is fine. Oh, log path probabilities. Okay, this is probably incorrect. Yeah, we have the thread ID. This is going over the actual ID, and this is going over these log path probabilities. But the problem is, if we are indexing it outside the loop, it will be reading the wrong values given the thread. The thread ID is actually this thing here. This I, that's the thread ID. I don't think it's used anywhere. Or actually it is. Oh yeah, I mean, it's used here. But I don't think it's used in local masked regret matching. this I think. Oh, it's used in the mask. Okay. Okay, so this is the thread ID. Thread ID. Thread ID. And if we're going to be reading this array in here directly, we need to actually use the correct thing. I mean, it's not the actual thread ID, but it's the row of the. I mean, it's the dimension. It's the outer dimension of the tensor corresponding to the original thread ID. Okay. Policy and value, and yeah, we are folding over it. Applying the sequence ID is fine because every thread will have the same sequence ID. And over here we have to apply thread ID. I mean, we can do that separately. Actually, let's do this like so. Log path probs. Okay, what's this? Oh yeah, this is the output. Let me just put it in. Put it like this, and this update value. Okay, this is a real problem. I mean, it does us not good. It does us no good to just set it high like this. Okay, so how are we going to deal with this? I mean, we have to move that inside the loop somehow. Sequence ID, thread ID. Yeah, we need to. Wait, what about the reward? Oh, god damn it. I mean, this is the reward. What about the path probability? Yeah, the fact that we have a thread ID here and thread ID in other places will no doubt complicate things. For fuck's sake. Okay, can we... Like, maybe we should then calculate the update, like, separately. we have the policy probabilities. I mean, we have the path probabilities. Yeah, it's basically what. Once I started to think about it, all started going back to me. The impact of the changes for the policy updates are so negligible back in 2021 that I forgot my thinking from back then. The only thing that really made an impression on me were the CFR updates. Okay, this update value, we need to set both the rewards multiplied by the path probability and then put the path probability as the denominator. And let me pause here so I can think about that. I had the time to think about it. You know, thinking back to what the actual values that we were getting are, as you can see here, they're pretty much, the policy updates are fairly large. Wait, oh yeah, okay, this thing here. And you can kind of get a sense for why Tabular CFR hasn't replaced the policy gradients in the deep learning arena. Even though this is correct, and in the tabular case, if you tried passing these kinds of values into something like policy gradient, into something like into a policy network and train it using policy gradients, the variance of the gradients would be very extreme, especially the deeper you go into the network. In order to, I mean, the deeper you go into the game tree, that's what I meant. And I tried to fight against this by using sign gradient descent. Sign gradient descent is where you just take the sign of the gradient and not its magnitude. And you know, maybe if you, given my attitude and how doubtful I am of gradient methods, it kind of made sense anyway. But and that wasn't enough to actually make this method work. And right now, these updates are pretty large, and we're only like we started with -13, and we're 5 nodes into the game tree, and this one is -700. So the magnitude of the update kind of grew by 50 times due to the effect of importance sampling. It's basically, it worked on LIDAC. A lot of ideas that I've tried did work on LIDAC Poker, which is a very small game. But once I tried it on non-limit hold'em, it basically didn't work. And this really makes me appreciate the tabular methods that much more. I guess my career as a machine learning engineer is one long lesson in the appreciation of tabular methods. So okay, let's get this to work. We're going to copy paste this. I guess we'll also do this here. This is the actual thread of the GPU thread in the block, and this is the row of this policy current and reward and count tensor. Policy current and value tensor. That is the input. the threads basically get transposed into inside this row gather map reduce. The threads get transposed, so they all handle the first row concurrently. But that kind of I forgot that this messes with the thread ID. So okay, we also have to calculate all this. Okay, well, what's the problem? This is f64. This is the exponent. We're not using the path probability anywhere, so let's do that. And we have to do this outside the row gather map reduce function because that kernel doesn't have the reward. We only have that in thread local storage. If we wanted to share it in this kernel, we'd have to do something like put it in global memory, or maybe even share memory. But you know, later we'll be calling this global wise. So sharing the reward in shared memory wouldn't work. Or maybe it would, depending on how we distribute the computation. But never mind that for now. So yeah, here we'll multiply the reward by the path probability, and we'll also put the path probability as the denominator. And we have to change this trace update value, so it we'll have to change its type. Okay, trace update. Yeah, trace update value. This is this, and this is going to be probability. Really? Yeah, I mean, it's kind of like an inverse probability if you think about it. Maybe you could put it as path probability. This is the action probability. I mean, okay, it's fine to just put it as probability, no problem. And this is now correct. And it's very convenient that we decided to make this trace update value. I was considering yesterday of maybe updating it directly in this. I mean, updating the model directly here instead of doing this, but I guess it's going to be necessary. Okay, it's kind of it pays to do things in multiple passes. It makes things a lot simpler when you understand what something is supposed to be. We have the calculation of the updates separate from their application, and it's very much a pity that we have to calculate the path probability twice. I wish we could yeah, I wish we could factor this out. So let me put a few words on this, why we're using exactly the same update for the value for the model values, much like we do for the model policies, for the model reward values. And it's pretty much, it's actually fairly similar to what I explained. Like if we had something like And if we have something like, let's say, 2, so as we mentioned, imagine these two are kind of alias to the same world state, to the same world ID. So they're kind of the same node in the, maybe not in the game itself, but in the model. So if we think about, and this node is estimating this value. It might have multiple actions, and these values are just the values for a particular action. And if we think about what a fair value for this would be, it would be to just take the average of these three. And the only way to actually take that average, because we're constantly sampling using some kind of arbitrary probability, if we wanted to accumulate the averages of these values, we have to divide by the sampling probability. So that is in fact being done here. And by subtracting the log probability, we are essentially dividing by the sampling probability of the entire path. And as to why we are also considering, why not just divide by the entire sampling probability and kind of assume that everything is, that everything is uniform? Why are we, for example, here we are omitting our own policy probability, but we are considering the opponent probability. So imagine, like, imagine this node is like, this node doesn't belong to player 1, but player 2. This green node, it belongs to player 2. But it has something like, and it has something like an action going from here. And then it also goes to this same node. And this same node might have some kind of very large action, very large reward. But because it might have a very large reward, but because the opponent is, it can control whether the player 1 gets to this node and then to this node, which gets to this large reward. And the opponent can just make the probability of ever getting to this node like 0. And if it does that, then it kind of makes no sense to, take the average of this large reward and these three. So it would be better to actually omit it. So that's why we actually consider the probability of the opponent or the environment when doing the value update. It's pretty much for the same reason why we're doing this for the policy update. I hope that makes sense. So basically, we don't want this to ever really be a part of the estimate. When the opponent is, for example, when the opponent has the probability of ever getting to this as 0, we can just ignore this. So that's why we are multiplying by the opponent probability. And that's basically it. And if we didn't do this multiplication by a path probability like before, it would pretty much average all of these values out according to the implicit sampling probabilities, and that would lead to weird results. The thing about the value updates, they aren't really strictly necessary for the algorithm to converge. Even values are all like always 0 or something else, the tabular sampling CFR algorithm will still converge. But without the variance reduction mechanism, the results will be a lot worse. In fact, using the same old ID for the value estimates as for the policy isn't necessary. And if you look at some of the papers, they enhance the model using hindsight information. And the hindsight information in something like poker, like imagine for the policies here, we have the sequence ID and we have the old ID. But this old ID kind of, this particular node doesn't have any information about the opponent's hands. But if we are calculating the hindsight information, I mean, if you're calculating the value, the expected value for a particular action, then it's actually beneficial to also include the information about the opponent's hands because it cannot influence the policy in any way. So for something like LDAC, I didn't really see much of a difference between the two methods. It still converges pretty quickly, for LDAC at least. So yeah, we have this. And what I feel like doing is factoring all this out, because we're going to have the same path probability calculation in both places. So get path prob thread ID path prob equals path prob thread ID. We don't want to change this and then not change this. We want these two path probability calculations to be bound together in terms of code path. So that's why we're going to do it like this. Let me just raise the table. Oh god, my hand hurts. I mean, even it seems like even lying in bed is putting pressure on my arm. It's crazy. I really hope this will get it better, but I don't know how. Yeah, now we have the path probability for a given thread ID. Yeah, and that's... Oh yeah, and this is, I think, very nice. Now let's just also fix the other error. Atomic add. Yeah, now we actually have the denominator, so we'll be adding it here. I mean, yeah, we really could just add it to the model directly. But then again, if we add it to the model like here, and then we calculate it here, that might lead to a race condition. I mean, we have to do something like a block barrier CTA sync barrier synchronization. And this kernel here, does it automatically at the end, so it's fine. Okay, I'm happy with this. I mean, it's kind of like, yeah, it's fine. Who cares? We're going to do it like this. Maybe in the future we might. Okay, let me just do to do. Maybe add it to the model directly. And we're kind of doing a loop 4 down, and then we're the update policy. What's the update policy? Trace update policy, sequence ID, thread ID. We're adding it to the policy update. Oh, yeah, we need to do that because otherwise we wouldn't know whether the policy has been updated. Of course, we're not just we're also updating and then decaying it. Okay, I'm going to pause here and think about what comes next. I think, we should be continuing with putting in print statements, but I got really into this and started thinking about things and kind of lost track of. I lost the momentum. So let me just pause for a bit so I can gather my thoughts, and then maybe we'll resume printing out the statements. I just realized something. This reward, this particular reward that we have here, you're getting that from the wrong thread once again. Oh, damn it. I mean, we wouldn't notice that during the testing because every thread has the same reward here, but we definitely notice that something is wrong during optimization. Okay. I mean, why don't I fucking name this as value instead of must this reward and count? For fuck's sake. Okay, that's one renaming. And I guess now we have to think about how we're going to pass the reward into this. Oh yeah, this is fucking amazing. I'm making so many mistakes because I'm simply passing getting the wrong scalar from lexical scope. Yeah, I really shouldn't be getting any scalars from gather map reduce. Okay. I mean, are we using gather map reduce like in here somewhere? Gather void action ID policy update. Oh, okay, this is a tensor. ID. Right, so we have the policy update, which has been applied with the world ID. And this update policy, sequence ID, thread ID. Okay, this is fine, but are we maybe adding to the wrong policy update array? Sequence ID, thread ID. Oh fuck, we are. Oh. Oh damn, this is really bad. Maybe in RowGather we should be passing in specific scalars and sharing them. Oh, this is simply impossible. Okay, let's also... Okay, this is raw map, so this should be fine. This is model. Okay, this, I think we aren't really getting anything wrong from the lexical scope. Okay, the sequence ID is the same everywhere. The thread ID, unfortunately, is wrong. Thread ID. Okay, we need the... action ID. Right, the policy update, that's... why is it being done like this? The update policy, we are indexing that with sequence ID and thread ID. And for this one, we need to apply the world ID. And then the action ID. Okay, I'm going to pause here. So we're first going to focus on how to pass the right reward into this function. We might have to extend the primitive, and we really should make it harder to grab the incorrect value from lexical scope. Yeah, right now it's too easy to make a programming error. I mean, I suppose we could just set the reward into global memory, then index into it. Okay, let me pause.